Chapter 9 Practical Geography. We will study the following points in this chapter. 9.1 Cartography. 9.2 Aspects of Maps. 9.3 Map Reading. 9.4 Statistical Diagrams. 9.5 One-dimensional diagrams. 9.6 Two-dimensional diagrams. 9.1 Cartography. Maps are the tools of geographers. Geography can be understood well with the help of maps. Geographical features are often represented by maps. The globe is a replica of the earth. It cannot be used to show detailed information of the earth. Hence, maps are used for representation of a part or whole of the earth's surface. Cartography is the art and science of mapping. A large amount of spatial information is represented by maps. Geographical features, economic data, population data, etc. can be shown very effectively on maps. 9.2 Aspects of Map. 1. Title. Map in Figure 9.1. A has the title India Physical and B has India Sex Ratio. 2. Extent. Map B's mainland extends roughly from 8 degrees north to 37 degree latitude and 68 degrees east to 97 degree east longitude. Map A has the same extent. However, latitudes and longitudes are not shown. 3. Scale. Map B is drawn to the scale. Linear scale is shown. 4. Direction. Both the maps have north direction. 5. Legend. Map A has a legend where different shades of colors represent height and depth in meters. Map B has different shades indicating different ranges of sex ratio in 2011 in different states. 6. Theme. Map A is a physical map of India where physical features such as mountains, plateaus, plains, rivers, lakes, etc. are shown with different colors. Map B is a thematic map mainly indicating the sex ratio in different states in India. Maps are basically divided into general and thematic maps. One needs to develop the skill to read maps and to understand them. Let us take information of physical and thematic maps of India and read them. In the previous class, you have learned the types of maps. This year, let us learn to read, understand, and explain them. Maps can be explained according to their title, scale, size, theme, color combinations, descriptions, and many more aspects. Let us read Figure 9.1a, Physical Map of India, and Figure 9.2b, sex ratio of India. Both the maps are different. So let us try to read them separately. For this, we have to take different aspects of maps as given below. Map in figure 9.2b. It is a map of India that has a very specific theme, that is, sex ratio of each state of India in the year 2011. Different shades are used for different ranges of ratio of females per 1,000 males. Besides shades of color, actual sex ratio of each state is also given. According to this map, Kerala has the highest sex ratio of 1084, whereas Haryana state has the lowest sex ratio of 877. Union territories like Chandigarh, Delhi, Dadra, Nagar Haveli, Daman and Diu, etc. have a very low sex ratio except Puducherry, which has 1038 sex ratio. Overall, Chhattisgarh, Odisha, Andhra Pradesh, Karnataka, Goa and Tamil Nadu have higher sex ratios as compared to the northern states of Jammu and Kashmir, Punjab and Haryana, whereas the sex ratio is between 801 to 900. Uttar Pradesh, Arunachal Pradesh, Nagaland, Rajasthan, Gujarat, Madhya Pradesh and Maharashtra have a sex ratio ranging from 901 to 950. 9.3 Map. Let us explain each map separately. A. Physical map of India. To the north of India, the Himalayas with a height of more than 6,000 meters above mean sea level can be seen. There are some hill ranges to the northeast of India. The Aravalli range lies in the west of India in Rajasthan. In Madhya Pradesh, the Vindhya ranges run in a west to east direction and the Satpura range runs almost parallel to them. The Western Ghats run along the coast from north to south with offshoots like Ajanta, Satmara Hills and Balghat range. In the south, the Nilgiri Hills and the Annamalai Hills can be seen. The Eastern Ghats are found to east of the Deccan Plateau, but compared to the Western Ghats, they are not very high. The Satluj and Ganga plains are found in North India. To the northeast, the Brahmaputra makes a flat plain. To the west, the Rajasthan desert is found. The Rann of Kutch is a marshy area situated on the west. To the east, from West Bengal to Kanyakumari lies a plain area. This is broader than the west coastal strip. There is a plateau region in the south and center of India where many rivers cut across the plateau. In the west, there are many islands near the Kerala coast named as Lakshadweep Islands, and in the east, far away from the mainland Andaman and Nicobar Islands are located. There are many river systems in India. Himalayan rivers like Beas and Satluj, etc. flow towards the west towards Pakistan. The Ganga system has Gomati, Ghagra, Gandak tributaries from the north and Yamuna and Son join the Ganga from the south. Brahmaputra flows from east to west in Assam Valley of India. Mahanadi, Godavari, Krishna, Kaveri and many other small rivers originating in the plateau region and flow in a west to east direction. Most of them make huge deltas. In the west Narmada, Tapi are the major rivers. None of them form deltas. 9.4 Statistical diagrams. Statistical diagrams represent statistical data. Everything that exists has some dimension. Things can have 1, 2, 3 or more dimensions. Length, area and volume of an object are measured with 1, 2 and 3 dimensions. A point is supposed to be a non-dimensional entity. Number of points joining together to form a line is called a one-dimensional diagram. A number of lines put together close to each other will form an area which is called a two-dimensional diagram. (9.5) One-dimensional diagram. Line graph and bar graph are one-dimensional diagrams. Line graph. A line graph is a one-dimensional diagram. In this graph, two elements are shown. Usually, time is shown on the x or horizontal axis and population or commodity value is shown on the y or vertical axis. Method. Read the data to find out the highest and lowest value. Accordingly, select the scale on both the axes. Mark time period on x-axis and the other elements on y-axis. Plot the points in the graph space with reference to the values on x and y variables by intersecting the two values. Join all the points with a smooth curve. Write the scale, title, and legend, etc. Uses. Line graph is very useful to express the trend in values over a period of time. Population growth, industrial growth, profit, prices, etc. can be visualized very easily. It is a very simple method which gives an immediate visual impact. Exercise 1. Draw a simple line graph representing population of India 1901 to 2011. Year, population in millions. Year 1901, 238, 1911, 252, 1921, 251, 1931, 278, 1941, 318, 1951, 361, 1961, 439, 1971, 548, 1981, 683, 1991, 846, 2001, 1028, 2011, 1210, provisional. Simple bar graph. It is another one-dimensional diagram. It is also known as pillar diagram or column graph. The height of the bar is proportional to the value of an element. When the variations are small, this method is very effective. The vertical axis indicates the production of commodity, while the horizontal axis shows various regions or time period. Exercise 2. Draw a simple bar graph to represent the following data. Year, per capita income in rupees. 2000 to 2001, 17,782. 2001 to 2002, 18,885. 2002 to 2003, 20,871. 2003 to 2004, 24,095. 2004 to 2005, 27,183. 2005 to 2006, 31,080. 2006 to 2007, 35,430. 2007 to 2008, 40,141. 2008 to 2009, 44,345. Source: Key Statistics of the Indian Economy. Method: find out the highest and lowest values of data. Accordingly, select a scale, plot the points that will determine the height of bars. Draw pillars or bars up to the plotted heights. Shade these bars for better visual impact. Write title, scale, legend, etc. Uses: bar graph is very useful for comparative study of elements of various regions. Agricultural production, industrial productions, population of various regions, etc. can be shown with the help of a simple bar graph. 9.6 Two-dimensional diagrams. Circle diagram, square diagram, divided rectangle diagram and pie diagram are two-dimensional diagrams. This year we are going to study only divided rectangle and divided circles, that is pie diagram. Divided circle or pie diagram. Divided circle is also a two-dimensional diagram. Different sectors are shown in a circle. A circle has 360 degrees which are divided according to the sectors given, that may be area or production. To calculate these divisions, the following formula is used. Angle of the sector is equal to sector data upon total data into 360 degrees. Method of drawing. 1. Select the size of radius. 2. Calculate the angles of sectors with the help of the given formula. 3. Draw a circle and divide it according to the angles calculated for each sector. 4. Shade the sectors. 5. Write the title and draw a legend to express each shade. Uses. This method is very useful to show population data like male-female, workers, non-workers, age compositions, etc. Besides population figures, it is also useful for land use pattern, export-import, etc. Exercise 4. Vehicle sale in India 2009 to 2010. Types of vehicles, number of vehicles, degree. Passenger vehicles 1 crore 94 lakh 9,776, degree 57 degrees. Commercial vehicles 53 lakh 1,395, 16 degree. 3 vehicles 44 lakh 368, 13 degrees. 2 vehicles 9 crore 37 lakh 1,231, 274 degrees. Total 12 crore 29 lakh 2,770, 360 degrees. Advantage: this method is very useful to compare data and understand the proportion of each sector as a part of the whole. It gives a very good visual impact. Limitation: it gives only one comparative picture looking at the diagram. It is difficult to calculate exact value. Divided rectangle. A rectangle is proportionately divided to represent different sub-factors of any data. It is drawn on the basis of given statistical values. Generally, data is in the form of percentage. If they are not in percentage form, they should be converted into percentage. The total area of the rectangle is considered as 100% and it is divided according to the percentage of each sub-factor. Since each subunit which is shown in the rectangle has a separate identity, each one can be shaded differently and a legend can be given to understand it easily. It is used for providing information about population, land use pattern, crops, industrial output, etc. Exercise 3. Agricultural production. Kharif in million tons, 2010 to 2011. Crops, 2010 to 2011 in percentage. Rice, 95.98, 43%. Coarse cereals, 43.68, 20%. Pulses, 18.24, 0.8%. Soil seeds, 32.48, 14%. Cotton, 33, 15%. Total, 223.38, that is 100%. Method: convert the given data into percentage. Decide the scale and the length of rectangle as per the size of the page. Mark the different units as per the scale. Shade the different units.